All right, welcome to The Explainer. For all you focus learners out there, get ready, because today we are going on a seriously exciting journey. We're taking a dense, comprehensive set of research methodology data and transforming it into a clear, actionable toolkit. We'll start with the foundational concepts of how we measure the world, and by the end, we are actually going to conduct a real-world post-game analysis of a methodology quiz, breaking down exactly why the wrong answers are wrong. So, let's jump right in.
It all really starts with this fundamental question. What is the first step in unlocking the truth? You know, a lot of people think research is just reading a bunch of books or typing a quick query into a search engine. But as we'll see from our source data today, research is so much more than just repetitive searching. It's this highly systematic, scientific approach to finding the absolute truth of a specific problem.
Okay, let's dive into this. Here is our clear 5-step syllabus for today. Foundations of research, measuring the real world, the art of sampling, formulating and testing hypotheses, and finally, our final quiz, deconstructing wrong answers.
Starting right off with Section 1, Foundations of Research.
Before we can analyze data or solve these complex business problems, we really need to agree on what we're actually doing. According to the source material, the primary definition of research isn't just finding a solution. It is defined as working in a scientific way to search for truth of any problem. That word, scientific, is the absolute anchor here. It means we are rigorous, we are objective, and we are following a structured process to get our answers.
Which brings us perfectly into Section 2, Measuring the Real World.
Once we know that research is a scientific search for truth, well, we have to know how to actually capture and measure the data we find out there in the wild. We've got 4 levels of data measurement here, going from the most basic to the most advanced. At the lowest level, we've got nominal data. This is just categorizing things, like asking someone what operating system they use, Mac or Windows. Then we step it up a notch to ordinal, where we can rank things, like social class. Next is interval data, which gives us equal distances between points, like temperature. And finally, the highest level is ratio data. This one actually has an absolute 0. Think of test grades ranging from 0 to 100, or a company's sales figures.
All right, let's test your grasp on this with a quick pop quiz taken straight from the source material. Imagine a market research analyst asks consumers to rate the appearance of a new package on a scale of 1 to 5, where 1 is awful and 5 is excellent. Which of the 4 measurement scales are we using here? Lock in your guess. Boom, if you guessed ordinal level data, you nailed it. It's ordinal because the rankings clearly have a logical order, right? A 5 is definitely better than a 1. But it is not interval or ratio data because the subjective distance between awful and excellent isn't some mathematically equal or guaranteed unit of measurement.
Moving right along to Section 3, the art of sampling. So we know how to measure our data, but how do researchers decide who exactly they're going to measure? You literally can't ask everyone in the world your questions. To ground this in reality is this great example from the source about Manuel Benales, the marketing director at Plano Power Plants. He wants to assess product features. Now, if he sends a survey out to all 954 of his 954 customers, he is ordering a census, checking the entire population. But if he only sends it out to 100 out of those 954 customers, he's pulling a sample.
And listen, when you pull that sample, how you do it matters immensely. If you select, say, every 5th female entering a mall, you're using a systematic, probability sampling method. Everyone has a defined mathematical chance of being picked. But if you just grab whoever happens to be conveniently standing nearby to answer your survey, that is non-probability convenient sampling. Sure, it's way easier, but it's a completely different ballgame in terms of scientific accuracy.
All right, shifting gears into application with Section 4, formulating and testing hypotheses.
We've got our measurement scales, we've pulled our samples. Now, how do we use these to test our big ideas? This story brilliantly illustrates it. Restaurateur Denny Valentine is looking at 2 sites for his next restaurant, Raymondville and Rosenberg. He has this sneaking suspicion that Raymondville residents dine out more often. So he pulls a random sample of 81 families from each suburb to test this. But before he can prove his theory, he has to establish a baseline.
Enter the null hypothesis, and please do not let this mathematical notation freak you out. mu1 minus mu2 equals 0 simply means Denny is starting with the baseline assumption, the null hypothesis, that population 1 and population 2 dine out the exact same amount. The difference between them is literally 0. He has to mathematically prove this null hypothesis wrong if he wants to confidently build his restaurant in Raymondville.
We see the exact same logic at play with Lucy Baker. She's analyzing the demographics of 2 television programs, Cops and 60 Minutes. Previous studies told her there's no difference in the average age of the audiences. To test this for herself, she pulls a random sample of 100 viewers from each show. Her null hypothesis? Once again, it's mu1 minus mu2 equals 0. She has to start by assuming the mean ages are mathematically identical.
And here we are, the climax of the explainer. Section 5, final quiz, deconstructing wrong answers.
Now that you have this entire toolkit, we are going to play detective. We're going to look at the final 2 questions of the source document's massive methodology quiz and break them down using process of elimination. Here is question 199. What is the main purpose of basic research? The options are A. Solve practical problems, B. Improve products, C. Advance knowledge, or D. Test a hypothesis. Take a second. Lock in your guess.
Okay, let's hack away at the incorrect answers here. We can immediately eliminate option A, solving immediate, practical problems. That is literally the definition of applied research, not basic research. And by that exact same logic, we have to toss out option B. Improving commercial products is highly specific, practical, business applied research. Basic research just isn't about immediate commercial utility.
So, the true purpose of basic research is C, to advance knowledge. It's all about building that fundamental theoretical foundation that the applied researchers are going to use later on to solve those practical problems. Great job if you used logical deduction to land on C. Let's see how this all comes together for our final challenge. Question 200, the ultimate question of the document. What is the first step in the research process? Options are A, data analysis, B, formulating a hypothesis, or D, defining the problem. Let's do a rapid-fire elimination based on the timeline we've built today. Option A, data analysis? No way. As we saw with Denny and Lucy, crunching the numbers happens at the very end of the line. What about option B, formulating a hypothesis? Well, think about it. You simply cannot formulate a mathematical assumption or a testable guess if you don't even know what the issue is yet. Which leaves us with D, defining the problem. And this echoes the earlier parts of our source material perfectly. Without a clear problem identified and defined, a researcher is basically just wandering in the dark, gathering completely meaningless data. You have to know exactly what you are looking for before you can ever find the truth. And that brings us to the end of our journey today. From measurement scales to null hypotheses, you now understand the mechanics of how we actually search for facts. So I'll leave you with this final provocative thought. The truth is out there, hidden in the data. The question is, do you have the right tools to define the problem and measure it? Go out there and apply these methodology tools to your own real-world questions. Thanks for joining me on this explainer, and keep questioning the data.